So when we did multiply, dividing, simplifying, we did all the same steps. We tried to reduce our PCS, our difference in squares, all of those things, and cancel off things that were the same, right? So with adding and subtracting, the same as adding and subtracting fractions. What do we have to have in order to add and subtract a fraction? Common denominator, right? The bottom of the common. Because if I do this to you, go back into elementary school, and they gave you a pizza, and they said this much was eaten. And then they gave you adding, and they gave you another pizza. Oops, pretend those are cut for in the middle. Bad. So this one is 2/4 of the pizza was eaten, and this one is 3/8 of the pizza is eaten. So of course we can just add them easily, which is the way they are. No, if I, oh my gosh, what is going on? Well, now you're really gonna have to turn up that shaker traffic. If I cut this one into 8 pieces now, instead of 2 out of 4 pieces, how many do I have? Eaten. 4 out of, now can I add them up? How many pieces got eaten? 7 out of 8, so almost the whole pizza. Everyone else is, I think, did everyone else get explained it? Yeah. 500 over 16, because you're adding how many pieces cut out. This was cut into 8 slices. They're all the same. This is cut into 8 slices. They're all the same. It's just actually still shaded properly. So this is 3 out of 8 were eaten. This is 4 of the exact same amount of 8 were eaten. So that's actually 7 out of 8. 1, 2, 3, 4, 5, 6, 7. So I took these red ones and I added them here. I would now have 7 out of 8 pieces eaten. Right? If I took these ones and transported them onto this pizza. I have 7 out of 8. Does that make sense? You cannot add and you cannot subtract fractional things without common bases, because how do you add and subtract those 2 pizzas? You couldn't have, right? Once I cut them into 8, you could totally add. Does that make sense? Rationals are the same. You cannot add and subtract rationals unless the bases are the same. Oh, look at these. What is this help thing? They're both out of 3 slices. The pizza has 2x pieces eaten out of it, and the other one has x pieces eaten out of it. So strange, not so much. But they're both out of 3, right? Our biggest problem with rationals is to get common denominators. I already gave them to you in this question. Sometimes that's how they always work. We make sure we have an equal sign running down the left-hand side, because these are expressions, not equations. They don't have an equal sign. Now, if I have 2x out of 3 pieces minus x out of 3 pieces, this is all out of 3 pieces. And now I can just add the top 2, right? So if I want to show them or subtract them, I can show the steps. 2x minus x. Are there any NPVs on this one? American, why not? So I have 2 x's. I subtract 1x. How many x's do I have? Think of x's like apples. And I'm saying this because so many people get this wrong, because most people don't do, now paying attention, most people do not do the actual steps wrong. You cannot collect like terms. It's like terms never made it to your repertoire. I'm not joking. That's where rationals goes downhill. It's collecting like terms. So, why treat x's like they are apples? Or xylophones we really like. Please start with x. Okay? So here, I currently have 2 xylophones. I take away 1 xylophone. How many xylophones are left? 1 xylophone. Done. Treat your X's like xylophones. Treat your Y's like yo-yos. I don't really care. Treat your phones like they should be in your pocket or something. I just call them apples. I don't know why, but apples. So that's how you get that. These things can absorb everything, right? Oh, I just call them mushy orange. As I said, you are a mushy orange pet, and then I just, yeah. All right. So, this is all of these are both over 5, correct? So we can put them all over 5 in common denominators. So, here we're going to go 2a minus 3 plus 9a plus 1. So once you have a common denominator, we just write our full numerator over it. Then our next step is to collect like terms. This is where you will derive, not the actual rational part, the collecting like terms. So here I have 2. Here I have 2 apples and 9 apples. So what do I have? 11 apples. True statement. And here I have minus 3 random guitars. And I add 1 guitar. And what do I get? Minus 2 guitars. That would suck. You didn't have a guitar, you just got 2 stolen. That is the situation. Unless you get a guitar. Then look at C and D. Aren't they wonderful? You try them. Okay. It's over 4 and over 4. So we're going to we're going to write it over all over 4. And then we have 3x plus 1x. Still no NPDs because it's just a 4 in the denominator. I have 3 xylophones. I add 1 xylophone. I now have 4 xylophones. Am I done? This is a monomial, right? So the 4s can actually cancel off and I can be left with x. 6. Let's see how many people get it right. I set you up not reminding you about a subtraction sign and a binomial. So let's see what happens. So use both over 6. Put it all over 6. Then we get 5y minus 1. And then I'm subtracting more than 1 term behind it, correct? I'm subtracting everything behind it. So I'm going to subtract the 4y, so I'm going to get minus 4y. And then I'm going to subtract the positive 7, so I'm going to get minus 7. You have to remember to distribute that minus sign through. If you forget to, it's the common error, it will be there. So when you have a subtraction sign and a binomial behind it, you have to subtract everything that's behind that subtraction sign. You see how there's a common error there? If you're someone who's a common error there, highlight it, star it. Remind yourself. Don't do that. Then we flip the term. We have 5 yo-yos. We subtract 4 yo-yos. We have 1 yo-yo. Then we have negative 1 something, minus 7 something. We get negative 8 something. Example 2. Still no MPVs, but I didn't give you what? Common denominator. I need to make common denominators. So what is common between 4 and 3? And common denominators are always bigger. So bigger or equal to 1 of the denominators, right? So if I have 3x over 4 minus x over 3, I need to multiply this one by 3. When I do the bottom, I have to do the top, and the reason why I have to do it to both is 3 divided by 3 is 1. It doesn't change anything. Right? It just makes it bigger. And then this one, I have to multiply by 4 and 4. And so I'm going to get 3x times 3 is 9x over 12. minus 4x over 12. Now we're just back to where we were. We have common denominators. If we have common denominators, we can write them over one denominator, right? So now I'm going to get 9x minus 4x all over 12. What's 9x minus 4x? What's 9 xylophones minus 4 xylophones? 5 xylophones. And no NPVs because there is no variable to my denominator. So sometimes I have to multiply both fractions to make a common denominator, correct? Sometimes, like B, I only have to multiply one of them. What do I have to multiply? Which one? The 3 by 2. And I have to multiply the entire thing by 2. So I'm going to get 6a minus 2. 6a minus 2 all over 6 plus 4a plus 5 over 6. And then we're back to like example 1, the common denominator. And the full numerator over one denominator. 6a minus 2 plus 4a plus 5 all over 6. And then I have 6 apples. I have 4 apples. I get 10 apples. I have minus 2 guitars. And I add 5 guitars. How many guitars? 3. All over 6. What's common to 8 and 3? 24. Multiply 8 and 3 and 3 minus. Try it out. This one? This one is multiplied by 3. The whole thing. This one we're going to multiply the whole thing by 8. So on the top, in the numerator, we're going to get 24y minus 9 all over 24 minus 16y plus 8 all over 24. We have to remember to subtract the whole binomial. So we are going to get 24y minus 9 minus 16y minus 8. We can't forget to do that 8. So then we get 24 yams minus 16 yams. I'm left with 8 yams, or they're like 4 yams. And then we have minus 9 flutes, minus 8 flutes. We get negative 17 flutes, and we're left with 4. I want you to try these ones. The only catch with these ones is they come denominators. What's the catch? NPVs. That's it. The only catch. So these are all over x. So I can write them all over x. I get 2 plus 7 minus 1, which is 8 over x. And what I have to say? X can't equal 0. B is all over 2a. So I get 5a plus 3 plus a minus 6. Now I collect my terms. So I'm going to get 5a plus 1a is 6a. And then 3 minus 6 is negative 3. Now I can take a 3 out of both of those. So I can write it as 3 2a minus 1 over 2a. And then some people tell me that 2a's can cancel. Is that true? No. The 2a minus 1 is a binomial. The 2a is a monomial. Can a binomial and monomial ever cancel? No. But I do have to say A can't equal 0. These ones are 3y minus 1 denominators, and I write all over 3y minus 1, which is a binomial, and we put in brackets. Then in the top I have 3y minus 1. Wait a second. They're the same, but before I cancel, I slap my hand and I say, and do these. So I go 3y minus 1 can't equal 0. 3y can equal 1. Divide by 3. Y can equal, these are exact same, so I get 1, not 0, and then y can equal 1/3. What's the catch with D? D has a binomial behind the subtraction sign, correct? So I have to remember to subtract both of those terms. So they both have x plus 3 in the denominator, so I'm going to write it all over x plus 3. But then I'm going to have 4x plus 10 minus 2x minus 4. If you're someone who keeps forgetting to distribute that minus sign, you need to leave yourself a note. There is a subtraction sign in front of more than one term. You have to subtract everything behind it. If not, you'll consistently make the same mistake over and over. So, I have x plus 3 in the denominator, and then I have 4 xylophones minus 2 xylophones, or 2 xylophones left, and then 10 trampolines minus 4 trampolines is 6 trampolines. Is there anything I can do to this binomial? So you got a 2. Then I'm left with x plus 3. Oh, remember 2? And we x plus 3 can't equal 0. X can't equal negative 3. Chop, chop. We cancel. And I'm left with 2. X can't equal negative 1. And I'll take pictures and post them too. But I'm not going to take this one. So we're going to be in our workbook on page 443. Sorry, 442. I lied. 442. Number 2. AC. 3. BD. 4 BD. 6 C. D. 7 A. Only 8 questions. I'll take a picture and post it.